Hello everyone, welcome back to my YouTube channel. This is Rakshita studying Electronics and Communication Engineering at Sri Venkateswara College of Engineering, Bangalore. Today we are going to discuss on a subject control system, subject code BEC 403 of topic block diagram reduction technique in control systems. Let's move forward. Introduction to block diagram reduction technique. Block diagram reduction is a powerful technique used in control systems engineering to simplify complex system into a more manageable form. This allows for easier analysis, design, and understanding of systems behavior and performances. Let's move forward to the importance of the block diagram reduction. Block diagram reduction is a crucial in control system as it helps engineers identify the key components, understand the relationship between them, and determine the overall system dynamics. This technique is essential for designing effective control strategies and optimizing system performances. Here you can see the feedback system on the screen. Let's move forward to the next slide. Basic rules of block diagram reduction. The basic rules of block diagram reduction includes simplifying series, parallel, and feedback elements as well as handling summing and branching points. Understanding and applying these rules correctly is vital for effectively reducing complex control systems. Reduction of series elements. Step 1. Identify the series elements in block diagram. Step 2. Replace the series elements with a single block whose transfer function is the product of individual transfer functions. Step 3. Repeat the process until the diagram is reduced to a single block. Let's move forward to the next slide. Reducing the parallel elements. Step 1. Identify the parallel elements in the block diagram. Step 2. Replace the parallel elements with a single block whose transfer function is the sum of the individual transfer functions. Step 3. Repeat the process until the diagram is reduced to a single block. Reduction of the feedback elements. Step 1. Identify the feedback loop in the block diagram. Step 2. Apply the formula for the closed loop transfer function to replace the feedback loop with a single block. Step 3. Repeat the process until the diagram is reduced into a single block. Reduction of a summing and branching points. Summing points. Replace summing points with a single summing block. Branching points. Replace branching points with a separate blocks for each branch. Repetitive application. Apply these rules repetitively until the diagram is reduced to a single block. Step-by-step procedure. Identify elements. Carefully examine the block diagram to identify the various elements such as series, parallel, feedback, summing and branching points. Apply the reduction rules. Apply the appropriate reduction rules to identify the block diagram one step at a time. Verify correctness. Ensure that the reduced block diagram accurately represents the original system behavior. Applications of a block diagram reduction. System analysis. Simplify complex system to understand their dynamics and performances. Troubleshooting, identifying the critical components and their interactions in the complex systems. Controller design. Facilitate the design of effective control strategies by reducing the system complexity. Education. Teach control system principles and concepts using simplified block diagrams. Conclusion and summary. Simplifies complex systems. Block diagram reduction is a powerful technique that simplifies complex control system into a more manageable forms, enables effective analysis. The technique allows for easier identification of key components and their relationships, leading to better system understanding and design. Widely applicable. Block diagram reduction has wide range of applications from system analysis and controller design to troubleshooting education. Let's see the solved problem on a block diagram reduction. Reduce the following block diagram using block diagram reduction rule. Here the block diagram is been given. Uh, let's solve this. Firstly, step 1, G1 and G2 are connected in parallel. Find its equivalent block G1 plus G2. Step 2, eliminate the summing point before G1 plus G2 having negative feedback H1 in closed loop system. Step 3, move summing point after G4 to before G4. Here you can see the diagrams on the screen, how we have reduced into a simpler block form. Step 4, exchange the position of both the summing points before G4. Step 5, G3 by G4 and G1 plus G2 whole divided by 1 plus G1 H1 plus G2 H2. Both blocks are connected in parallel. Find the equivalent block. Step 6, eliminate summing point before G4 having negative feedback in a closed loop system. Here you can see the block, they have been reduced. Step 7, find the equivalent of both the cascaded block. Single block diagram representation as shown below. Here we get the final block diagram reduction. Thank you for watching my video. Please do like, share and subscribe my channel.